Hello everyone, welcome back to the channel. If you are following along, we have started this series of completing maths portion of CSAT 2025 with the fundamentals of number system. In the first video, we covered the basics of number system, and today we are topping the next topic of number system, that is remainders. So again, if you're just revising your concepts, or you are starting fresh, these videos are for you. Last year we did this course, it was good. This year we are going to complete the math portion, plus we will try to take some classes or doubt session. We'll see how the time allows us, right? So let's start with the today's topic. So what exactly are remainder? To understand remainder, you need to know the division, right? Normal division which we do in our class, basic 6th, 7th, 8th class. So how do we divide the number by another number? So let's say if someone asks you divide 27, divide 27 by say 5. How do you divide it? Remember this method? Very Indian method where we put in 27 here, 5 on this side, and then this is how we do the division. So if say this number is 27 divided by 5, then 5 5s are 25, and you are left with some number 2. Correct? I hope this is clear. Now, what are the different portion of this division? This part is known as quotient. Quotient. This part is known as divisor. Divisor. And whatever we are left with, this is known as remainder. Correct? So, remember these three terms. Remember these three terms. Now, S is your original number, that is 25. So 27. How can we represent 27? 27 can be represented by multiplying divisor by quotient and adding a remainder to it. I hope this is clear. Just remember this formula: multi divisor into quotient plus remainder, and you are going to get back the original number. Right? This formula is going to be best friend for you to solve the remainder problems. Right? Now, how can we say 27 is, what is the divisor? Divisor is the number we were dividing 27 with, that is 5. Multiply with the quotient. What was the quotient? Quotient was 5. So what we have got here, this is 5 plus remainder. Remainder is 2. So this is how you can break down a number into divisor, quotient and remainder. Correct? Moving on to the next part. Now, if we say a number is completely divisible by the another number, so if the remainder is 0, means in the last example, when we divide 27 by 5, what was the remainder left? Remainder left was 2. So if any remainder is left, means it is not 0. We say that 27 is not divisible by 5. But for some reason, if the remainder would have been 0, we would have said that 27 or whatever number is completely divisible by 5. I hope this part is clear. Now let's take an example of 625. 625 divided by 5. This 5 is what? Divisor. Now start dividing. 1, 5, 1, 2. Then you do 5 to the 10, 25. 5 5s are 25, and you're left with 0 here. So if now the remainder is 0, this is the quotient and this is the divisor. So if the remainder is 0, we can say 625 is completely divisible by the divisor, that is 5. I hope this is clear. This part is clear. Now moving on to the remainder theorem, the most important topic in today's section. Now we know how to calculate the remainder. First thing we know, that is how to calculate the remainder. When we divided 27 with 5, what was the remainder that was left? 2. Now this is easy because we know this divisible is easy. But suppose I ask you, now give me the remainder when 27 plus 32 plus 62 plus 92 plus 89 plus 68 and so on is divisible by 5. Give me the remainder of this number. Means there is a number which is formed by addition of a lot of numbers, and then give me the remainder that is you get after dividing it by 5, right? So first thing is you can do one thing, that is add all these numbers 27 plus 32 plus 62 and so on. Or in our example, suppose this is a number which is formed by adding three numbers, that is 46, 32 and 29. One thing you can do is add all these numbers. You can add all these numbers, you are going to get some 100 and something. So if you do that, then divide it by 5 and you can find the final remainder. That is a long method. Easy method would be find individual remainder. Individual remainder, individual remainder, right? So when 46 is divided by 5, is it easy to find the remainder of that? Yes, very easy. When 46 is divided by 5, you have a remainder of 1. You can calculate that, you are left with remainder of 1. When 32 is divisible by 5, you get a remainder of 2. When 29 is divisible by 5, you get a remainder of 4. So what are the remainders of individual number? That is 1, 2, 4. Now the complete number you can do, just put in the plus sign here. You are left with 4 plus 2 is 6, 1, 7. So 7 is the remainder. 7 is the remainder. But always remember, remainder is of a number is always between 0 to n minus 1. Means if we say this number is divisible by 5, so the possible values of remainder could be 0, 1, 2, 3 and 4. 5, if the remainder is 5, that means the remainder is 0, correct? So if you are left with 7, do the division again and calculate the final remainder. So if I divide 7 by 5 again, 7 is divided by 5, you are left with remainder of 2. So 2 is the final answer of this question. Correct? Easy. Rather than adding all these number and then dividing it by 5, what did we do? We calculate individual remainder, find the final sum of the all the remainders, then if since it was greater than 5 or 7, you divided it again by 5, then you are left with remainder of 2. Correct? Easy. Now moving on. Remember this part, that how can we calculate the remainder of some numbers. If we go to the next part, this remainder theorem is exactly copied to the multiplication part as well. So multiplication part is, there are three numbers which are multiplied and they are asking you, give us a remainder when it divides by 5. One thing you can do is multiply 46 by 32 and that by 29. It is going to be a very very long number, and then you can divide it by 5 and then it going to give you an answer. That is one way of doing it. Then, but that is not the correct way. What is the correct way? You find the individual remainder first. Again, individual remainder is 1, 2, 4. And now what are you going to do? You can do a multiply. 1 into 2 into 4. Right? 1 into 2 into 4 is 8. Now, since 8 is greater than 5, do division one more time. Division one more time and you are left with remainder as 3. I hope it is clear how to use remainder theorem of addition and multiplication. Now, I want to give you one more last tip. Addition, we have already learned. Multiplication, we have already learned. Subtraction means if three numbers are 46 minus 32 minus 29, whatever you want to say, three number are subtracted. You can use the remainder theorem here as well by calculating the individual remainder and just using the same sign. But this theorem fails in the case of division. Just remember that this cannot be applied to a division. It can only apply to a addition, multiplication and a subtraction. I hope this is clear. Now moving on to the next part. Next part is this number, this question. What is the remainder when 1991, 19 plus 1992 plus 1993 are divided by 7? So how to do that? First thing, either I can do the summation of it, then do the division by 7, or calculate the individual remainder. Suppose I calculate the remainder of this by 7. 7, 14, 59, 7, 56, 31, 28, 3. So this is going to give me a remainder of 3. This you can calculate, this is going to give me a remainder of 4. This is going to give me a remainder of 5. So 3, 4 and 5 are the individual remainder. I am going to sum all of them. So it is going to be 5 plus 4 plus 3 is 12. Since 12 is greater than 7, divide it again by 7 and you are left with 5, which is the final remainder. Correct? Easy? This is how you could solve the question or remainder theorem. Now, next part. This question is for you. Practice on your own. Similar question and important. The application of remainder theorem to the actual question. And you can expect similar question in the exam. Correct? Now, moving on to the next part. What is the concept of negative remainder? What is the concept of negative remainder? So, if 13 is divided by 7, so 13 is divided by 7. If I divide 13 by 7, so I have 6 as a remainder. Correct? So, when 13 is divided by 7, I have a 6 as remainder. So there is one way of looking at it. Suppose I say 0, 1, 2, 3, 4, 5, 6. 7 cannot be a remainder because if I am left with 7, I divide it again by 7 and I will again get a 0. So these are the possible value of remainder when I divide a number by 7. Correct? But if you say 6 is my remainder, 6 is my remainder, I am going to add 7 to it. Right? 6 plus 7 is 13. 6 and 13 are equivalent for 7 because if I am left with 13, I can divide it by 7 and I am left with 6. And if I remove 7, I am left with minus 1. So minus 1 is also a remainder to it. How? Because I hope let's understand it from this perspective. Let me remove this part. So 7, 13, you are left with 6, right? So 7 and 13, there is a gap of 6, right? If we add one more, we could have gotten 14 and the remainder would have been 0. So between 7 and 14, these are the two numbers. Here we have remainder as 0, here we have remainder as 0, but 13 is giving me a remainder of 6. So there is one way of looking at it, that it is 6 far from the nearest multiple, that was 7. So it is, if 7 is the multiple, then it is plus 6 of that multiple, or I can simply do a minus 1 from it. What was the other multiple of 7? That is 14. So if I just do a minus multiple of 14, means I subtract 1 from 14, I'm still going to get a 13. How? Let's look at it. This might look a little tricky at this point of time. Don't worry, but it is quite very easy. So one way of writing 13 is 7 into 1 plus 6. Remember this the first slide? This was a remainder. What was the other way of writing this 13? The other way of writing 13 is 7 into 2, 7 to the 14 plus minus 1. Correct? Am I clear? So this minus 1, we can also use this formula where this is quotient, this is 2 is quotient, this is divisor, and you are left with a remainder of minus 1. This is not wrong, this is totally correct. And this is where the negative remainder concepts comes in. Correct? So the 6 and minus 1 are similar. So if I say 13 is divided by 7, so remainder could be 6 or remainder could be minus 1. Both are correct. Now 15 into 14 is divided by 8. What is the final answer? 15 into 14 divided by 8. So one thing you can do is you can do individual remainder. So 15 is divided by 8, you have 7. 14 is divided by 8, you have 6. You multiply this, 6 7 is 52, and then you divide it by 8 and you can get the answer. One method. Or the other method is use the concept of negative remainder. 15 and 14 divided by 8. We know that 15 gives a remainder of 7 in the case of divided by 8. But is it not 7? Is it not 7 equivalent to -1? Correct? Because if 15 is 7 far from 8, it is just 1 less than 16. So 15 gives a remainder of -1 when divided by 8. 14 is -2. And how did we calculate -1 and -2? Whatever remainder you have, 7 and 6, you can subtract 8 from both and you are going to get the negative remainder. So 15 gives a remainder of -1, 14 gives a remainder of -2. Multiply these two, you are going to get a +2 as an answer. Correct? Easy method. Rather than going by the positive integer, where it was giving me 52 and then doing a long calculation, this is another way of doing it by using the remainder, negative remainder. Now, let's see this question. 7 into 7 into, so this is given that 7 raised to by 21. When it is divided by 50, give me the remainder. So one is, you have 21 times 7. How many times? 21 times 7 are multiplied. So now you don't know when you divide it by 50. Obviously, you are going to get again 7. This is going to give you 7. This is going to give you 7. That is going to give you 7. So the positive remainder is not going to work in this case. How can we use the negative remainder? If I do this, this is 49. 7 7 is 49. This is with 49. So I am going to do the pairs and 49. So this 27's 20 times 7 is going to give me 10 pairs of 20 pairs of 7 is going to give me 10 pairs of 49, and there is one 7 that is left because we are total 21 sevens. Correct? Now how many pairs of 49 we have? 10 into 7, right? Now what is the remainder of 49 when divided by 50? You can say the remainder of 49 divided by 50 is 49, or you can also say it is -1. I hope now minus concept is clear. -1, 10 times. -1, 10 times. Into, again 7 remains 7 because we are keeping 7 aside. I hope this is clear. Now -1, 10 times is going to give you positive of 1 into 7. So 7 is the answer. I hope you understand how did we use the concept of negative remainder in this case, because using 7 was not easy. We are not aware, doing a long calculation is not easy. But we know that 49 gives me a remainder of -1, and that is how the pairing was done. Now we are just approaching to the end of this video, and this is the last topic, and that is one of the important topic, that is common factor. Let's start. So what is 2 raised to power 96 divided by 96? What is the remainder? Question first go, it might look a little difficult because 2 raised to power 96 you are not aware. 96 very difficult because calculating it will going to take a lot of time. So what is the how we are going to use the concept of remainder theorem in this case? First thing is write 96. How can we write 96? Let's say 8, 12, 8 is a 96, correct? Or am I doing anything wrong? 12, 8 is a 96 is correct. So 12, 8 is a 96 is correct. Can I write it like this? 2 cube means 2 raised to power 3 is 8, and this is 4 3 is a 12, so 2 square into 3. So just prime factorizing it means 2 raised to power 5 into 3. This concept we are going to learn in the next video of prime factorization, but for now just break down the number 96 into its prime factorization. Means 2 raised to power 5 into 2, 5 into 3 is also what? Is also 96, correct? So 2 raised to power 96 divided by 96, can I write it like this? 2 raised to power 96 divided by 2 raised to power 5 into 3. Anything, did I do anything wrong? No, easy. So simple mathematics, I can remove 2 raised to power 5 from denominator and numerator, and you are left with 2 raised to power 91 and divided by 3, because I am I am deducting 2 raised to power 5 from numerator and denominator, correct? But have a safe, have a have a locker on the side and keep this 2 raised to power 5. Just don't throw it away. Just keep it with you because we are going to use it in the end. So 2 raised to power 5, I'm just keeping it aside and you are left with 2 raised to power 91 divided by 3. Easy? Now, is it easier? Was this easy or this easy of finding a remainder? Obviously, second part. How? I will do 2 into 2 into 2 into 2 into 2 into 2 2. How many times? 91 times. So, how I am going to pair it? So, I have 90 times 2 and 1 2 extra. Just keep it aside. How I can change it to 4s? So, 4 into 4 into 4 into 4 into 4 into 2 extra. This is 45 pairs of 45 pairs of 4. Easy? Now, tell me, what is the remainder of 4 when divided by 3? That is 1. So, it is 1 into 1 into 1, 45 times into 2. This 2 is still continuing without any modification. So, we have 1 into 1 into 1 into 1 into final 2. So, your final answer is 2 as a remainder. But, in this case, you cannot leave 2 as a remainder. So, the final remainder in your answer is 2 which you have got into, bring back 2 raised to power 5 from the locker and your answer is 2 raised to power 6. Am I clear? So 2 raised to power 6 is 4, 4, 16, 64. So 64 is the final answer in this case. So the only concept you need to know that whenever there is a common factor and if you are removing that common factor, don't just throw it away. Keep it in a locker, do the calculation and bring it back. If this looks tricky to you, I would highly suggest watch it again, understand this concept because before going ahead, I will just tell you from where the questions could be asked. Going back, this is where the first thing is they can ask you the remainder theorem. Such type of question could be asked a plus b plus c, a multiply b multiply c, very likely. Negative remainder concept, you need to understand the concept of negative remainder, but the questions would be asked like this. 7 raised to by 21 divided by 50. You have to be very clever of finding a pattern that if somehow I am able to find 49, I can solve this question. Correct? Now, this one is clear. This is the type of question and the common factor was the last topic we have learned. Here we did an example and this question, very high likely the question like this could be asked in the exam. Correct? Now, this is the practice question. I am leaving it for you. Here, the concept of negative remainder is going to be come handy to you. Use that and find the answer. Put the answer in the comments. And if you are struggling to solve this question, please make sure you also post in the comments. Either I will solve it in the next video or some other aspirant is going to put the answer in the comments. I hope this is clear. So that's all for today. Please, if this video helped you, make sure you hit the like button and please share it with your friends because this course is going to help a lot of people with their quant section because there is no structured course available on YouTube who gives you like where we have all the topics segregated into topic and subtopic wise. So that is where this course is going to be very handy. Second thing, this course is free. You don't have to enroll into anything, don't have to pay anything, and rest assured, if you follow along all the courses, your theory will be done here and here. You just need to then after that you just need to practice previous year question and that's it, right? So see you in the next video and till then, goodbye.